speeds is weight reduction, which means new designs for many of the train's most vital components. Higher speeds also require measures to mitigate environmental impacts. Today we find out how the next generation Shinkansen will be faster than ever. Hello.
Hello.
Welcome to Science Zero.
Today we take a look at Japan's super-fast new bullet trains.
Apart from maglev trains, the world's fastest wheeled train now in service is the French TGV, which can travel at 320 kilometers an hour. Japan's fastest is the Sanyo Shinkansen, which tops out at 300 kilometers an hour. But the next generation version will reach 320, as we're about to see.
Here's the prototype, called Fastek. It's pretty cool.
Well, the shape is kind of elongated. Well, in late 2010, the Tohoku Shinkansen line will be extended to the city of Aomori. Fastek is the prototype of the new bullet trains to be introduced on that line.
And I had the great privilege of riding along on one of its test runs.
So let's get started by introducing our commentator on the program today. Professor Shinji Suzuki of the University of Tokyo is a professor of aeronautics.
Well, the development of bullet trains is actually quite closely related to aircraft development. Japan wasn't allowed to have aircraft after World War II, so aeronautical engineers worked on the Shinkansen instead. My own research these days is in the field of aeronautics, but some of my students have gone on to work on the Shinkansen. The two fields have a lot in common.
The goal for the next generation Shinkansen is to make it faster, but it's not just a matter of pushing up the speed, there are other obstacles too. Now, what kind of research is involved in overcoming them? Well, we'll answer that by looking at three topics today.
First, up close on a test run, the quest to shed weight, and reducing environmental impacts. I got the chance to ride along on one of Fastek's test runs. So join me for step one. It's about 10 minutes to midnight. I'm the only person left here on the station platform, but the Fastek will be pulling in soon. Here it comes. Can't see it very well yet. Midnight, and I'm face to face with the Fastek for the first time. Wow, what an odd shape. Sort of strangely elongated. That's the first impression, but it really looks cool. Wow. It doesn't look like your everyday bullet train, does it? The Fastek is going through a series of experiments to help it reach higher speeds. The test runs are being conducted on the actual Tohoku Shinkansen line track. The data that's collected will be used when the next generation trains are finally built. Oh, someone's getting off. Good evening. Nice to meet you. This is Hitoshi Shiraishi, my guide for this trip. He works on the development team. I couldn't help noticing right from the start that the train's nose looks very long.
Well, you're quite right. It's actually 16 meters long. That's longer than on any other train of its type in the world.
That's amazing. The nose is definitely the Fastek's most distinctive feature. It looks like a duck's beak. Okay, now it's time to get on board. It's departure time, 12:13 a.m. Today, the Fastek is making a test run between Sendai and Kitakami stations. Oh, we're moving.
But let me show you around the inside. Please come this way.
So this is what it's like.
Now this is the measurement laboratory for the various tests we'll be doing.
There are 15 people working on this test run. That's to say, the railway workers and the engineers from the companies involved in manufacturing the various components. What's this?
Well, right now this device is measuring the angle of tilt of the interior to make sure that it doesn't become uncomfortable for passengers when the train goes around curves.
The Fastek is equipped with a device that automatically tilts the cars to help them navigate curves at higher speed.